Hello, everyone. My name is Aleah Lynn, and I'll be presenting my material science final project on solid diffusion. What is diffusion? Diffusion is mass transport by atomic motion. Atoms move in a predictable fashion to eliminate concentration differences and produce homogeneous uniform compositions. Due to the thermal motion of atoms, materials go from an area of high concentration to low concentration. What is solid diffusion? Diffusion can occur in solids, liquids, and gases. Specifically, solid diffusion refers to diffusion due to thermal activated random motion of atoms, unless the material is at absolute zero temperature. Individual atoms keep vibrating and eventually move within the material. Stability of atoms. The ability of atoms and imperfections to diffuse increases as the temperature or thermal energy increases. The rate of movement is related to the temperature and thermal energy by the Arrhenius equation. Activation energy. A high energy is required to squeeze atoms past one another during diffusion. This energy is the activation energy. Generally, more energy is required for a substantial atom than for an interstitial atom, which we will get into later. Fick's first law. The rate at which atoms diffuse in a material can be measured by the flux J, which is defined as the number of atoms passing through a plane of unit per unit time. So these are all things that describe how diffusion varies and things that will make it increase or decrease in the elements that are associated with diffusion. So temperature, a higher temperature will result in solid diffusion happen more rapidly. Also, we need a high activation energy to be able to start the reaction. So there are mechanisms that diffusion occurs in solids. The first one I will be talking about is our interstitial diffusion, which occurs if a solute atom is sufficiently small and moves into a position between the larger solvent atoms in an energy favorable configuration. Atoms move from an interstitial position to another intersite nearby. So I had an image of this on the first slide, where you can see the atoms are moving in between others and they're smaller atoms. The next one I will be discussing is self-diffusion. Atoms move from one lattice position to another. This process is known as self-diffusion and can be detected by using radioactive tracers. Although self-diffusion occurs continually in all materials, the effect of the material behavior is not significant. So this would be example B. So the next mechanism I'll be discussing is vacancy diffusion. The vacancy diffusion occurs when an atom on a normal lattice site jumps into an adjacent unoccupied vacant site. It turns out that only adjacent atoms move into vacancy. The rate depends on the concentration of vacancies in the lattice. So this would be example C. You would have an atom move from, it will usually be a hole in the compound, and the atom will move to that space, and then there will be a vacant spot in a different position. And then the last mechanism that I will be discussing is interchange diffusion. Diffusion of unlike atoms in materials also occurs. So diffusion of copper atoms into nickel. Eventually, the copper atom are randomly distributed out through the nickel. So this is example A. I think I said self-diffusion was A, but this is B, sorry. So applications of material processing. Diffusion is required for the heat treatment of metals, the manufacture of ceramics, and the manufacture of transistor and solar cells. So some of the different ways that we see diffusion in material science is grain growth. So grain growth involves the movement of grain boundaries, permitting some grains to grow at the expense of others, which you see in A and B. You can see like the pattern kind of change. And this is really important with crystals. Diffusion bonding, which is what we talked about with the copper nickel, is a method to join materials. Sintering is the high temperature treatment that causes particles to join together and gradually reduce the volume of pore space between them. Why is this important? Diffusion controls a wide range of technological processes associated with synthesis of materials. The process by which we modify materials include diffusion creep, sintering, pore formation and annihilation, grain boundary migration, grain growth, phase transformations, and precipitation. Without diffusion, these processes cannot occur, and neither can the transformation of materials. So these are just my STL files of the 3D model. And I will show you that here. So basically, I'm showing diffusion by combining two materials and how it would look. So you would start with like two compounds and they would come together and look something similar to this. I'll show you all the sides. Yeah. And the last thing I just want to say is that we've been talking about diffusion since elementary school, but now it's just gotten a little bit more complex. But diffusion is in everything. It is what I like to call like the balance and the combination of things. When we were taught when we were younger, when we smelled perfume, how it would go through the room. And now we're talking about how we can use it in our future careers with a combination of materials and how much heat is important when we're using diffusion in our later jobs. So that's the end of my slideshow. I thank you all for listening, and I hope you all have a good rest of your day.